Hi guys, welcome to Feynman Scholar, and in this video we will be starting and understanding what is electric dipole, and we will be differentiating it from electric dipole moment. And I hope you like this video. Comment in the comment section and subscribe to my YouTube channel. Thank you. So let us begin. So let us understand what is an electric dipole. So electric dipole is a system in which we have taken two equal and opposite charges. That means their magnitude is same and they are opposite in sign, and these charges are separated by a small distance of 2a. So in this picture we see that there are two charges. We have taken plus q charge over here and minus q charge over here, and these two charges are separated by a small distance of 2a. And since these are separated by a distance of 2a, therefore from the center to this to any one charge the distance will be a, and similarly to another charge it will also be a. So this is the representation of an electric dipole. Now we have a formula based on this. There is no derivation for this formula, so here uh, the formula is P is equal to 2aq. Here the P represents electric dipole, the 2a represents the distance between the two charges, and q is the magnitude of the charge. Here we have not taken any two charges but only the one charge and its magnitude. Since both the charge have same magnitude, that's why any one was enough. So let us differentiate electric dipole moment from electric dipole. So electric dipole moment is similar to, or it is exactly electric dipole only, but it is represented in vector form. That's why it is called electric dipole moment. So the formula before it was P is equal to 2aq, and since now we are making it into vector, we'll add a vector sign over P and over 2a, because 2a is the distance. Q is charge, and charge is not a vector quantity, therefore there won't be any arrow on the top of Q because it is a charge. So here this P represents electric dipole moment, which is vector quantity, and 2a and q are the same as before. That is, 2a is the distance between the two charges and q is the magnitude of the charge. So electric dipole moment, it is a vector quantity and its SI unit is coulomb meter. And there is one important thing to note here, that the direction of the dipole is taken positive to negative. So here the direction of the dipole will be something like this. Let's say this is the positive charge and this is the negative charge. Then the direction will be starting from the positive to the negative. This is only in physics. In chemistry there is something else. In chemistry you might have noticed in class 11, whenever dipole was taken, we see that the uh, direction of the dipole was always taken from the negative charge to the positive charge. Whereas in physics we see that the dipole direction is taken from positive to negative. So now let us revise what we have learned. So we have learned that electric dipole is when we take two charges which are equal in magnitude but they are different, or they have different sign, and they are separated by a small distance 2a. This distance is usually very small. It is taken in micrometers or nanometers sometimes. We learn the formula for an electric dipole, that is P is equal to 2aq. Here this P represents electric dipole, 2a represents the distance between the two charges, and q is the magnitude of the charge. We also differentiated electric dipole from electric dipole moment. The only difference between them is that electric dipole moment is the vector representation of electric dipole. Therefore the formula of electric dipole, which is P is equal to 2aq, it becomes P is equal to 2aq, where P is represented in vector form and 2a is also represented in vector form. Q is not represented in vector form because Q is a scalar quantity. The SI unit of electric dipole moment is coulomb meter, and the direction of the dipole is from positive to negative. Remember that positive to negative is only in physics. In chemistry, the direction of dipole is from negative to positive. In physics, it is positive to negative. So that's all for this video. We will be going through next topics uh, of electric dipole in a new video. So I hope you like the video. Comment in the comment section, and please subscribe to my YouTube channel. Thank you.